There comes a very, very interesting question from NCERT. They are talking about feasibility of a reaction using the standard potentials given in table 3.1. That is a table which we have seen earlier, right? This table they are talking about. This classic NCERT table in which electrochemical potentials are mentioned. You have to use this table and determine if the reaction of these combinations is actually feasible. We'll take them one by one and see. How do we do this? Let's start. You'll see. Let's take the first one. Ferric and I minus. Tell me, in case ferric and I minus react, what possibly could they have done? Well, ferric can undergo reduction and it can form ferrous. I minus can undergo oxidation and it can form I2. Oh my God. Is this reaction feasible? We will have to check. How exactly? Delta G naught negative implies feasible. Okay. But delta G naught is minus NF E naught. That should be negative. That means E naught should be positive because N and F are always positive. If I multiply by minus 1, the inequality sign reverses. That means if the reaction has to be feasible, then E naught cell has to be positive. So all I need to do is to calculate E naught cell. But do I know the formula? Of course. E naught cell is E naught cathode minus E naught anode. And in this case, cathode is the one which undergoes reduction and that is ferric. So this is E naught of ferric to ferrous minus E naught of I2 to I minus. Because this is undergoing oxidation and we are supposed to quote the SRP value of that. If I look in the table 3.1 as they have mentioned, I would discover the values as 0.77 volts minus 0.535 volts. Is this positive? Of course it is positive. If it is positive, that means E naught cell is positive, which means that delta G naught is negative, which means that the reaction is feasible. There we are. It's feasible. Done. Similarly, we can do all three. Yes, the remaining three also can be done with a very similar concept. Every time I will not repeat this, but this is the criteria, right? Let's do that. Ag plus, the second part now. Ag plus aqueous and copper solid. I mean, how could they react? What would happen? Well, Ag plus would be reduced to Ag and copper would be oxidized to copper ions. Something like this. Oh wow. Now, E naught cell for this reaction is E naught cathode minus E naught anode. Which is cathode? Which undergoes reduction. And who undergoes reduction? Silver undergoes reduction. So let's take that as cathode. This is E naught of Ag plus to Ag minus E naught of copper to copper ions. Cu2 plus to Cu. You can say this is anode. Fine, but we are writing SRP, so we have to write like this. And because anode, we have put a minus sign. That's a part of our formula. If you check in table 3.1, what do you get? You get Ag plus to Ag is 0.8 volts minus copper ions is 0.34 volts. Is this positive? I'm not even bothering to calculate it. Is it positive? Yes. Is E naught cell positive? Yes. That means this means delta G naught is negative. That means, is it spontaneous? Yes, it is spontaneous. Is it feasible? Yes, this is also feasible. Now let's explore the possibility of the third one. I'm not saying this is feasible, I'm just saying we're talking about third one. Ferric and Br minus, just like ferric and I minus. Ferric is coming so very often actually. So we could do actually third and fourth together. We have ferric with Br minus or silver. Let us see if they are feasible. Let's take a look. See, if ferric ions are treated with maybe Br minus, or if ferric ions are treated with maybe silver, what exactly happens? Ferric may get reduced to what? Of course to ferrous. And what about silver? Silver gets oxidized to Ag plus, or Br minus gets oxidized, of course, to bromine. It's a very, very similar story. E0 cell is E0 cathode. Now cathode is where reduction occurs, which is ferric ions to ferrous, minus E0 anode. Anode is where oxidation occurs, Br minus to bromine, like this. Do I have the values? From table 3.1, you could look at the values. This is 0.77 volts minus 1.09 volts. Oh my God, this is negative. Yes, it is negative. Is it feasible? No, this is not feasible. Therefore, delta G0, which is minus NFE0, is positive. That means this is not feasible. So this was yes, this was yes, this is a no. Oh, what about the fourth one? Very similar. E0 cell is E0 of ferric ions to ferrous minus E0 of Ag plus to Ag. If I look at table 3.1 and discover the values, this is 0.77 volts minus 0.80 volts, which is minus 0.03 volts. Small, but nonetheless negative. It is negative, goddammit. That means it's not feasible. No, it's a no, it's a no. YYNN. And the last, bromine and ferrous intend to react. Now, if bromine intends to react with ferrous, what might they do? Well, bromine would get reduced, Br minus, and ferrous would get oxidized. It would give you ferric. Oh, that's nice. How do I solve this? E0 cell would be E0 cathode. Cathode is the reduction occurs. The E0 of bromine to Br minus. Why? Because this is where reduction is happening. What about cathode? Sorry, anode. Anode is where oxidation occurs. That is the definition. Minus E0 of, this is 1.09 minus 0.77 volts, which is positive, yes. So is this reaction feasible? Yes. And actually, if you care to see, fifth is just reverse of third. If third is non-spontaneous, fifth, because it is just reverse, fifth is bound to be spontaneous, and yes, it is. So the answers are yes, yes, no, no, yes. This is how we do this.